Hi everyone, welcome. Morteza, can you hear me okay?
Hi, Rally. Yeah, I can hear you.
Great, thank you. Welcome everyone. Thanks for joining today's live webinar. Hope everyone is well. My name is Riley and I assist in coordinating our various free webinars that we hold every month that are posted on our events page on our website. I'm here in our head office in Perth, Western Australia. Today's session is a technical topic webinar. Is an introduction to virtual power plants presented by Dr. Seyed Morteza Alizadeh, one of our lecturers based in our campus in Melbourne, Australia. We like to keep these webinars as interactive as possible, so please use the chat box if you have any questions or thoughts you'd like to share during the session. If we still have some time at the end, we will have a Q&A session which you can ask any questions in which we'll try to answer for you while we're live. These webinars are recorded and you will receive a copy of the slides and the link to the recording in an email within the next 2 business days. We also offer a free digital certificate of attendance for these webinars. We'll provide a link at the end of the session to an online form in which you must complete in order to receive one. And a certificate of attendances will also be sent out in the next 2 business days. We have one of our friendly course advisors, Lebo, who's based in our South African office, in the session as well to answer any non-technical questions in the chat box. Without any further delay, I would like to hand over now to Dr. Morteza, who will be presenting this technical topic webinar for us all today. Thanks, Morteza. If you could just give a brief background of yourself and introduce yourself to everyone, that would be great. Thank you.
Sure. Thanks, Raleigh. Hi, everyone, and welcome to this webinar, which is about the virtual power plant. The main objective here is to give you some ideas about what virtual power plant means and how it operates. As a short introduction about myself, I'm Seyed Morteza Alizadeh. I graduated with a PhD in electrical and power systems engineering from Victoria University, Australia. I have done research about the power systems for over 10 years, and my research focused on renewable power plants and distributed generation systems. I published the results of my research in more than 30 papers in different journals and conferences. Also, I've been cooperating with IEEE or Springer, NDPI, and some other global technical professional organizations such as IEEE or some other organization as a technical committee members to chair the conference sessions or also as an editor. Currently, I'm leading a special issue in the Journal of Energies. I've been working with EIT for 2 years, and currently I'm coordinating research and research training here at EIT. Now, the topics we'll be covering today are first definition and components of a virtual power plants or VPP. So what does VPP mean in general and which components it has? Then we look at how the VPPs work. Here we discuss about how VPPs operate physically and also financially, and what benefits it offers to the participants. Then a case study will be shared. The case study is about the largest VPP project implemented here in Australia. And finally, opportunities and challenges facing VPP. So as we all know, VPP is still a new concept, and there is a very good potential for virtual power plants to grow in the future. But at the same time, there are some challenges that slow down the VPP's growth. So we'll talk about how the VPPs continue to operate from this point onward. Now that we have only 1 hour or even less, so I want to give you some ideas about what VPP means for everyone that is involved. To start with, first of all, we should define the VPP and who can be involved in this concept. Now, virtual power plants are very new, as I said, and so there is no set definition, but I think this one explains the VPP quite well. An aggregate of controlled, medium, and or small scale distributed renewable energy resources, the storage systems, and flexible consumers that can trade energy with the grid to provide services typically provided by traditional power plants. So now, based on the definition, a VPP has three components. The first one is controlled, medium or small scale power systems that are based on renewable energy, and also storage systems and flexible loads. These systems that you can see in this figure are called VPP assets. And I will use this term in my webinar for many times when we go further in this webinar. Now, another VPP component is the grid that you can see in this figure on top. So the grid or network operator. And finally, the last VPP component is an aggregator. From the definition, we know that it should be aggregated. So aggregator or VPP operator is needed to integrate the VPP assets and the grid to let them to work with each other. Now, let's move to other slides to see details for each one of these components. Now, in terms of VPP assets, as I said, these are small systems and can be divided into three groups. First, we have small or medium-sized renewable power plants, such as wind or solar farms, with the capacity of, let's say, 100 kilowatts or a little bit more. Most of the VPPs in Europe, and especially in Germany, they are based on medium-sized renewable power plants, especially wind farms. These type of VPP are called supply-side VPPs because their assets are only some supply system or generation systems. The VPP assets can also be flexible loads. Flexible loads such as a smart refrigerator with a thermal storage system. So these loads can adjust their consumption based on the grid stability. What does it mean? For example, in this figure, the load curve is shown by the blue color. You can see that around 9 p.m. here, the load demand is on peak. Now, during this time, the power generation may not be enough for feeding the load in some days. So in that situation, the flexible load gets turned off to reduce the load. So when they are off, the load curve will decrease by this much that you can see in red color. Or there is also another scenario that you can see in this part of the figure. In this scenario, the power generation in the grid is too much and is more than the demand. So this is the demand and this is the power generation. For example, in this figure, the power is generated by a wind farm or renewable system. It's shown by yellow. And you see that around 12 p.m., the wind speed is very high, maybe because of a storm, and when the wind speed is very much, then wind farm generates power, or maybe more than what is expected or was needed. Then this power needs to be reduced, because surplus power is also not good for the grid. So in this time, these flexible loads, they get turned on to absorb the power, to absorb the surplus power from the grid. So generally, the flexible loads respond to the grid requirements, or respond to the grid stability requirements, and they try to make the grid in a stable condition. Some VPPs, especially in the United States, are based on flexible consumer or flexible loads, and they are called load-based demand response, or DR VPPs. Another type of VPP assets are the small size renewable systems. Like a house with a rooftop solar panel, which has a battery as well. So the power from sun can be also stored or saved in the battery for later use. So this type of VPP is called mixed asset VPP, and we have this model in Australia. And because here we are using a storage system like a battery or electrical vehicle, so the power can be saved or can be stored, and this gives more flexibility to the system or to the VPP to support the grid by injecting power to the grid when it's needed. So power can be stored and can be available at any time. So this means more flexibility. Now, as you saw, another component of VPP is the grid. Some of you may be familiar with how our electricity network is set up physically. So it starts with generating station. Especially in this part of the grid, we have thermal power plants that generate electricity in bulk, and the electrical power then goes to high voltage transmission network. So the voltage level here is very high, and then the power goes to distribution substation or distribution network, and the power is then distributed to industrial sites, commercial sites, and also residential sites. Now, where is the virtual power plant? Virtual power plant is connected to the distribution part of the grid. So it's not generation part, it's not transmission. VPP is connected to distribution. And this is because VPPs are installed at the very end, close to the customer, close to the final loads. And their physical limitation don't let them to affect problems upstream of their given locality. Finally, the last VPP component is an aggregator. From the VPP definition, we know that it has an aggregator, or VPP has an operator. So the VPP operator is in fact a central control room that directs the whole system through software. So this control room directs the whole system virtually through software. In fact, the word virtual is because the VPP assets, these are small systems, they are accessed through software and VPP operator. rather than a physical generating facility. Now, why aggregation is needed in a VPP? Because the VPP assets have a low capacity. So, for example, here, if sorry, yeah. For example, here in this VPP, the VPP is based on rooftop solar panel and the batteries installed at house. Now, as we can see in this figure, then the capacity of the battery installed in the house for a solar system is not more than 10 kilowatt. Here, you can see the capacity of two home batteries. One is from Tesla, which is up to 7 kilowatts, and another one from ABB, which is up to 2 kilowatts. So a house battery with such a small capacity cannot be a power plant, because the capacity of a power plant should be at least 1 megawatt. But when we combine these small systems, when we combine these batteries in the houses, we combine hundreds or thousands of these batteries, then the whole capacity will be large enough, and then we can call it a PP, or we can call it a power plant. So aggregator or VPP operator is needed to combine these small systems to each other and direct them virtually through the software. Now, in the following slides, I'll talk about how VPPs operate and what the role of VPP operator is. Now, the VPP operation can be discussed from two perspectives. One is from the grid perspective, and one is from the assets perspective. Now, from the grid perspective, the VPP is to help the grid in being stable, especially during the peak time or during the peak demand. For example, in the figure on the right side, you see the daily load curve in a test grid or in a test system. In this grid, in years 2008, 2013, and 2018, on average, the grid faced with two daily peak loads. One peak load is between 6 and 7 a.m., and another peak is around 7:30 p.m. So during these hours, it's hard for the grid to feed the load. And so in some days, the grid power might be less than the demand. And when the grid power or generation is less than the demand, then the voltage goes down, and the grid faces with under voltage problem. And when we say under voltage, this means the grid voltage is less than the standard value, and this means the grid stability will be at risk. So we don't want under voltage problem, or we don't want over voltage problem. So what the VPP does in this situation, first of all, when there is under voltage situation, the VPP operator shut down the flexible loads to reduce the peak load, to relieve this peak. And also, if the demand is still high, then the VPP sends power from these small systems, from these assets, to the grid. So from one side, VPP reduces the peak loads by these flexible loads, and from other side, it sends power from the assets to the grid and helps the grid to be stable during the peak time or during the peak demand. Now, let's see what the VPP operator does from the assets perspective. Because the VPP is in fact using this small system's power to support the grid. So VPP needs to motivate these systems, needs to motivate the owner of these systems to participate in the VPP program and to cooperate with the VPP operator and generate power. Then that power can be given to the grid. So VPP motivates these systems mainly by giving them financial benefits or basically by giving them money. So these small systems are not eligible to sell their small power to the grid, directly to the grid. They cannot send it or sell their power directly to the grid because the market in the grid side is very big, and it is called wholesale market. So there are big utilities here. There are big utility providers that generate power in bulk and sell their power, huge power to the grid in the wholesale market. So wholesale market is where the big producer or companies are there. That's why these small systems cannot sell the small power directly to this wholesale market. But instead, the VPP operator trades the energy with the wholesale market on behalf of these small systems. And then the VPP pay money to these assets. So the rate of that is paid to the VPP assets is called feed-in tariff. So they will be paid based on feed-in tariff. And also, during the time that the power of these systems is not enough, of these assets, is not enough to feed the loads, which are covered by the VPP. For example, if the power needed by this house, by the equipment in this house, is not enough for the equipment of the house. If the device in the house needs more power than the solar energy, then in that case, the VPP send power from the grid to the load. And this is done with a low rate. So VPP see what time the rate is low, then it sends power from the grid to the consumer, to the load. So generally, the virtual power plants the operator of the virtual power plant trades energy with the grid and the wholesale market on behalf of the assets. And this is to make sure that these assets can get the highest profit from this market. So the VPP operator is doing two jobs, or the job of VPP operator is both technical and financial. Technical because it supports the grid, and the grid stability should be provided. And financial because the VPP operator gives money to the assets or to the participants. So how the VPP operator can do the job well? Now, to make sure that there is enough support for the grid during the peak time, the VPP operator predicts the power that can be generated by its renewable power plants, for example, by the small wind farms or by the small solar systems. So it predicts the power of these power plants for each day. So for each day, the VPP operator forecasts the wind speeds to see how much power the wind farms can generate. And it also predicts the sun energy to see how much power can be generated by the solar systems. And also the operator monitors the charge of the battery installed in the houses to see how much charge is available in each battery in each day. And also operator receives a report from the electrical vehicle owner to see how much power these electrical vehicles can give to the grid if needed. And also for each day, the VPP operator predict the amount of load or predict the load behavior for each day in a year. Now, in the case of asset profit, to make sure that the participants or the assets can get the maximum money or profit because of trading the energy with the wholesale market with a good price, the operator, VPP operator, needs to predict the electricity and also the carbon price. So operator see how much is the price of electricity in the wholesale market every day for each hour. Now, based on the predicted results, then the VPP operator prepare a schedule for each small systems or for these assets to say how much power needs to be produced or how much power needs to be generated and needs to be sent to the grid, and at which hours this power needs to be sent to the grid. So this schedule will be prepared for these assets by the operator. Now, the prediction is part of the work. The prediction is done into two phases. Because of time, I'm not going through details, but just give you some information. The prediction is done into two phases. One is long-term prediction using historical data recorded for the weather situation, for the wind speed, for the solar energy, or for the load in each day of previous years, for example, in the last 10 years. And another phase of prediction is short-term prediction using online or live data. So lots of data needs to be processed, and many trades needs to be done between operator and the grid every day. Here in this figure, on the right side, it shows the amount of data exchange per minute in one of the biggest European VPP, which is in Germany, and it is called Statkraft VPP. So this VPP has 1,300 assets. You can see that in this VPP, the software deals with 50,000 data sets per minute. And also the number of trades per day is 10,000. So this is a huge amount of data that must be processed by the VPP software. So the VPP software processes the data using complex machine learning algorithms or artificial intelligence methods. And also the data is transferred through Wi-Fi. So the data between operator and assets and the grid, this data is transferred through Wi-Fi or communication services. So the communication service should transfer all data Otherwise, if some part of data needs to be transferred, then the VPP operation will be adversely affected. Well, in the next couple of slides, we see how the VPP is implemented here in Australia. And also, to stop me from talking, let's watch a short video that briefly explains the VPP model in Australia, and then we can continue.
As Australians install rooftop solar panels at world-leading rates, the electricity network is transforming. New technologies like home batteries, electric vehicles, and internet-connected appliances are providing unprecedented energy independence and reducing our reliance on the power stations that have fed the grid for decades. That's great news for individual households, but the growth of distributed energy resources is creating challenges for the network. To boost the stability and reliability of the network, ARENA is helping to build virtual power plants that harness the power of hundreds or even thousands of individual home batteries to soak up excess rooftop solar power and act as one big battery when the grid needs an injection of energy. Able to be controlled remotely by aggregators and market operators, virtual power plants can capture the collective potential of other distributed energy resources like electric vehicles and smart appliances to provide a renewable way to stabilise the network and maintain a dependable supply of electricity as the energy transition advances.
Well, thank you. Okay, so in this video, which was about the Australian model, you saw that the VPP is mainly based on rooftop solar panel and batteries that are installed in the house. So let's have a more investigation or look at this model. So during the sunny days, the solar energy is used to turn on the home appliances through this inverter. So the solar energy, which is DC, will be changed to AC through this inverter, and then it feeds the load. And a part of the solar power is then stored in this battery, again through this inverter. So inverter communicates with the house battery. And this inverter is also controlled by the virtual power plant operator. Here, one of the limitations in VPP is that the link between the operator and the battery is this inverter. But inverter can only work with some specific types or some specific models of battery. For example, this inverter in this figure can only work with Tesla power, but maybe it cannot work with LG or ABB power battery. So the battery has to be compatible with the inverter, which is selected by the VPP operator. Now, the VPP operator has the authority to send a command to this inverter to discharge the battery for a certain number of times in 1 year, for example, for 30 times per year. And then the battery power is transferred to the grid So the VPP operator doesn't discharge the whole battery, and it makes sure that there is a minimum reserve in the battery. For example, 20% charge is always in the battery. So the battery owner, this householder, can use the battery reserve when there is a power out. So also in the days that the sun energy and the battery charge, these are not enough to feed the house loads, then VPP send power from the grid to the house. So the VPP must always be connected to the grid. And this is a very important point in VPP concept. VPP must always be connected to the grid. It cannot operate without grid. We don't have a VPP without grid. VPP is always connected, because if it's not connected to the grid, then it cannot feed the load of the house when this renewable power system cannot generate enough power. Here you see that the house is physically connected to the grid through this smart meter. And the role of a smart meter is to measure how much power is sent from the house battery to the grid and how much power is sent from the grid to the house. So for the power sent to the grid, so for the power that is sent from battery to the grid, the householder is paid as per feed-in tariff. And for the power that is sent from the grid to the house, then the householder has to pay based on a tariff which is usage tariff. Now let's look at a case study. As I said, the case study for this webinar is about the biggest virtual power plant in Australia. The project has been implemented by 2 retailers and 1 battery vendor. So one retailer is AGL, another retailer is Simply Energy, and the battery vendor is Tesla. So AGL, Simply Energy, Tesla, they invested on 3 VPP programs in South Australia. First, let's see the VPP program that AGL is running. Now, in this VPP, AGL is the VPP operator. So if someone wants to be involved or participate in the AGL VPP program, they must be house owner. They cannot be a tenant. And they need to sign a contract with AGL. The householders have to pay for the solar system and for the battery and for the installation. So AGL doesn't fully cover the cost for solar system and for the battery and for the installation. So this needs to be paid by the householder. Now, the type of battery that is accepted by AGL VPP program is Tesla power and also Tesla battery and LG battery. So these 2 models are supported. And the electricity that the householder gets from the solar panel and from the battery is free of charge. So whatever they get from their solar system, it is free because they already paid for the solar systems. But in contract with AGL, it is mentioned that the VPP operator or AGL can use the battery and can discharge the battery up to 30 times per year. But it is guaranteed that there is always 20% reserve in the battery, even when the battery is discharged. Now, the benefit for the battery owner is that, first of all, they get a 1,000 Australian dollar discount for the battery. Also, when they sign the contract, they get $100 credits, and also they get 50 cents per day, or about $180 per year, just for making their battery available to the VPP operator or to the AGL, regardless of whether the battery is discharged or not. So just because the battery owner accepted that the VPP operator can use the battery anytime that they want, they get $180 per year. So it doesn't matter if the battery is discharged or not. This is a fixed money. But if the battery is discharged, again, the battery owner will be paid as per feed-in tariff. We can see the feed-in tariff here as well. Another VPP program in South Australia is running by Simply Energy, which is another retailer in Australia. So here the operator, VPP operator, is Simply Energy. It's similar to AGL VPP program, but the incentive for the house owner is a bit different from what AGL VPP participants are getting. But let's look at the incentives. When someone participates in Simple Energy VPP program, they will be paid, or they will get a $100 credits because of signing the contract. Simply Energy also pay $0.66 per year, or 66 cents per $0.66 per day, or 66 cents per day, which is about $240 per year for the battery availability. So if the participants accept that Simple Energy can have access to the battery, regardless of whether the battery is discharged or not, they will get this much money. From the previous slide, you saw that AGL pay $180 for the battery availability, but Simple Energy pay $240, which is a little bit more. Also, whenever the VPP operator or Simple Energy discharges the battery, it pays to the battery owner, or it pays to the householder as per the feed-in tariff. And finally, the last scheme or program in South Australia is Tesla VPP program. So Tesla is the VPP operator. In this scheme, in this program, the householder shouldn't necessarily be house owner, they can be also tenants. So tenants can also participate. And the project has 3 phases. Phase 1 and phase 2, they were already completed. And phase 3 is still ongoing. So in the first phase, 100 tenants participated. And in the second phase, 1,320 tenants participated. Now, the main characteristics of this program is that Tesla pay all the money for solar system, for the battery, and for the installation. So the solar system or solar panel, battery, and installation is free of charge for the participants. But the householder have to pay for their energy. So it doesn't matter if the energy or if the electricity is coming from the solar panel or from the battery that is installed in their house, or if the electricity is coming from the grid. Doesn't matter. From whenever it is coming, they have to pay the money. But the money that they are paying is based on a very low rate. This rate is currently the lowest rate in Australia, and it is 22% cheaper than the standard electricity price in Australia. So that can be the main incentive or motivation for the people to participate in this VPP program. Tesla can discharge the battery, but it makes sure that there is always 10% reserve in the battery. So this reserve can be used when there is a blackout or power out in the grid. Now, I want to quickly review the main challenges that the VPP faced with. Well, the VPP challenges can be discussed from 4 aspects. The consumer aspect, and the fact that the VPP operation heavily relies on the power produced by its assets. So the engagement of the assets and their understanding about the VPP and their role in the VPP is very critical. For example, you saw in the previous slide in the Australia model that the assets are in fact the solar panel and the battery installed at houses. So some householders may not like it that the VPP operator can discharge their battery or basically have control over their battery. So they don't like it. And because of that, some of them may lose their interest in participating to the VPP program. A technical issue is mainly about the battery and inverter. And as I said, each VPP uses and accepts limited number of inverter and batteries. So the models of battery and inverter is limited. And the customer doesn't have many options. And another technical issue is about maintenance. Battery needs maintenance. Another challenge is about communication between VPP assets and the VPP operator. As you saw in the previous slide, this communication is usually done through Wi-Fi and public telecommunication networks. So sometimes the network may get disconnected. You may have communications drop out. So data cannot be transferred through the internet. And when some data is not transferred, as you saw, the VPP operation will be adversely impacted. And from a study, it was found out that on average between 5 and 8% of data is not transferred through the internet in VPPs. And the case of communication, another problem is, of course, cyber attack. And the case of markets, from the market perspective, the growth of VPP causes a low generation reserve and low minimum demands. Now, another challenge for VPPs is the similar technologies that can basically, these similar technologies can be a competitor for VPP. For example, microgrid. As you may know, microgrid is a self-sufficient energy system that fits the loads in a specific location. For example, in a campus, a college campus, or hospital, or in a shopping center. And microgrid is connected to the grid, to the national grid, through smart switches. So when there is a fault in the grid, the microgrid can be disconnected from the grid, and then it can work for a long time, maybe for a few days. But as you know, VPP cannot work without grid. So this is one of the differences between VPP and microgrid. Here you can see some of the main differences between VPP and microgrid. For example, as I said, microgrid can be off-grid, can be disconnected from the national grid, but VPP should always be connected to the grid. Grid is limited in terms of location. So it has a geographical limitation, but VPP doesn't have this limitation. So in terms of area, VPP can cover wide area. Finally, what's the VPP ongoing trials and how would be the VPP market in the future? Well, this figure shows the global virtual power plant market size in 2019 and what is estimated to be in 2027. So it is estimated that the market size of VPP, which was about $1.3 billion in 2019, it grows to around $5.9 billion in 2027. So this means the VPP market will be growing at a compound annual growth rate of 21.3% from 2020 to 2027. Here you can see some of the main reasons for VPP growth in the future. For example, one reason can be rising demands for renewable energy in power generation sector, and the fact that governments are considering strict regulations to penetrate decentralized or distributed renewable power plants, which are environmentally friendly, compared to traditional power plants. VPPs are more effective in dealing with peak demand or peak load, and they can quickly help the grid to feed the peak load, but this cannot be done by traditional power plants. And also, VPP makes the electricity market more competitive, and this makes the electrical power price, the electricity price, to be low, which is good for the householder, and this makes them motivated to participate in the VPP programs. And it's predicted that Europe will have the largest VPP market in the future because most of the companies and that big companies that are investing in VPP projects or VPP programs, they are all based in Europe. For example, ABB or Siemens, they are all in Europe. But in terms of growth rates, Asia Pacific region, country in this area, they are expected to be the best in terms of growth rates, with a compound annual growth rate of 26.5% from 2020 to 2027. And in North America, the United States is expected to lead the market and has the highest demand for VPP. And finally, the last point from myself is that the VPP operator is basically the heart of VPP, and it directs the participants virtually through software. So in my idea, the growth of VPP depends on the further development of the software that is used by the operator. Yeah, that's it from me. Thank you very much for listening. I'm happy to take any question.
Thanks very much, Morteza. That was a great presentation, and I think everyone found that really informative. There's been a lot of messages coming through the chat box. Would you just be able to go to the next slide, please?
Sure.
Okay, so everyone, if you want to attend an upcoming webinar, we've got a couple coming up over the next couple of weeks. One going into the field of mechanical engineering and an overview of our courses in that field. So that's next week if you want to look at that one. And we also have a technical topic webinar on digital manufacturing and Industry 4 technologies the week after. So be sure to check our events page on our website. The link is there as well. And if you want to go to the next slide, Morteza, I think, yeah, so a lot of people have been asking about our certificate of attendances. So as mentioned earlier, I'm now providing a link in the chat box. So please fill out the form on this link to receive your certificate of attendance, and they will be sent out in the next 2 business days. So thank you very much for that. And in terms of the slides, those will also be sent out to you with the video recording in the next 2 business days. And now our next slide, Morteza, I think we'll just do a quick Q&A session for a few minutes. If anyone has some questions for either of us, that would be great. So just pop your question in the chat box if you have any. Karam has asked a few questions, and he's asking if a virtual power plant can be designed to act like a virtual microgrid to maintain power quality in a smaller area of a bigger city or grid. Would you be able to comment on that, Morteza?
Yeah, microgrids, this is mainly based on, so in terms of size, in the VPP, the assets or the participants, they are small size. But in the microgrid, the size is a bit larger or bigger. So in the microgrid, you may see medium size or even large power plants. But in VPP, we don't have this, big assets. So to make a microgrid to be like a VPP, we can consider a microgrid to be a VPP, but it's not in the other way. So a VPP cannot be like a microgrid because the size of the assets are small. But for microgrid, they are the potential to act like a VPP.
Thanks, Morteza. I appreciate it. We've got a lot of questions coming through. I would just like to say to everyone, if your question is not answered during the session, we'll go for a few more minutes. But if your question is not answered, Morteza, if you could just go to the last slide. We have all of our contact details there. You can reach us by email or phone, or go on our website to look at any of our courses or make a general inquiry. So we'll go to the next question. Azaldo has asked, what is the difference between a virtual power plant and distributed generation?
Distributed generation, yeah. So distributed generation is basically one of the participants of the VPP. So distributed generation, like a wind farm, or it can be like a market turbine, or can be solar systems. So these are distributed generation systems. And a VPP use many of them and direct them to send the power or to exchange their power with the national grid. So VPP is in fact between the distributed generation systems and the grid, and direct these two to work with each other.
Thanks, Morteza. I can see there's a few messages about the link that I've provided in the chat box. It may not be working due to the large amount of traffic going to that page at the moment. So I'll put the I'll put the link in the chat box again, but if the link is not working for you, just please save the link and refer to it later. If there are any other problems persisting, please just send an email to the webinar at EIT.edu.au email address on the screen. Kevin has asked Morteza, what are the types of virtual power plant software?
For software, I could find some of the software for VPP. I know one of them is used by Statkraft VPP in Germany. I cannot remember the name exactly, but there are a few software tools that our VPP operators are using. But more importantly, in the software, the important thing is the algorithm that is used. So which algorithms can be used to have a good accuracy in the prediction, which basically artificial intelligence methods can be used, or which methods can be used to provide a good results, a good prediction results. So I think that is the important things about the software. For the software, honestly, I cannot remember the name of the software tools, but the important point in the software is the algorithm that is used, or the method that the software is using to solve the problems or to predict the results in order to schedule for the small assets.
Thank you, Morteza. We have another question from Benneth. What are the efforts targeted towards overcoming the challenges you stated earlier about the effectiveness of virtual power plants?
So this depends on the type of assets. If the assets, for example, for Australia model, the assets that we are using in Australia, they are, as I said, they are solar systems and batteries that are installed in the house. I'll shared in the slides what incentive the companies, the VPP operators, consider to motivate people to participate. And the challenge, I also talk about the challenge about the consumer side or the asset side. The main problem or the main challenge about the assets can be their understanding about the role and how important is their role in the VPP system or in the VPP concept. Some of them, some people may decide to participate, but when they sign the contract with a operator, for example, with AGL, in the contract it's mentioned that the contract should be for 5 years at least, or for some years. So if they want to withdraw from the contract, so that will be a problem or challenge for the VPP operator. So yeah, there are some strategies or some schemes from the VPP operator to keep the participants or to keep the assets motivated to participate.
Thanks, Morteza. I think we'll just go for a couple more minutes, as yeah, we've still got a lot of questions coming through, but unfortunately, we're not going to get to all of them. But we have a question from Emmanuel, and he's asked, in the case study that you presented on with the 3 providers, does one have to purchase and own the solar battery and solar panel, or is it provided by the service provider?
Yeah, for AGL and for Simple Energy, the householder have to pay for the solar systems and for the battery and for the installation. But for Tesla program, everything will be provided by Tesla. So Tesla pay for the solar system and pay for the battery and for the installation.
Okay, thank you for clarifying that. I think we'll finish up about there, everyone. I know there's been a lot of questions coming through, but unfortunately we've just run out of time. Hopefully the link for the certificate of attendance will work for you over the next over the next hour or so, depending on the traffic. But yeah, hopefully that will work for you. And as said, the slides and the recording will be sent to you in the next 2 business days. So so watch out for that. And thank you to everyone for attending the webinar, and thanks Morteza for presenting on this topic. So thank you, and have a good rest of your day.
Thank you very much, everyone, and hope you enjoyed this webinar. Have a good day.